Welcome. Today we're going to solve a pre-algebra problem from the AMC 8. The problem is this. We want to find the sum of the digits in the answer to the number given by 94 nines times the number given by 94 fours. So I really like this problem because when you look at it at the face value, it looks very difficult. So it's not like we can line these up and multiply it out like you learned in second grade math. You've got to be a little bit more clever about it. So usually when I see a problem like this that looks extremely complicated, what I try to do is replace it with a simpler problem, and hopefully through progressively making those simpler problems closer to the problem I'm trying to solve, you can come to a pattern that'll help you solve the original problem. So let's go down that path and see where it takes us. So the simplest problem related to this problem that you can think of is just multiplying 9 times 4. And that's just 36, and the sum of those digits is 9. Well, that by itself is very helpful, or is not very helpful. You can't find a pattern with just one case. So let's go to this next hardest problem that we can do. That would be 99 times 44. So that's still pretty straightforward. Add them up. 6 plus 4 is 10, plus 5 is 15, plus 3 is 18. So now we can make an attempt to go back and look for a pattern. So I do see something. 18 is a multiple of 9, so the pattern could be 9, 18, 27, 36, and go like that. So if that was the case, then when we calculate the next one, we should expect to get an answer of 27. So let's do that and see if our prediction comes true. So at this point, the multiplication, while still doable, is starting to become a little bit tedious. So one thing I notice on this is that 999 is very close to 1,000, which is a power of 10, and it's really easy to multiply numbers by powers of 10. So let's rewrite this problem as 1,000 minus 1, which is our 999, times 444. So when we write it out like this, then we can easily translate it into a subtraction problem. So we have 444,000 minus 444. So let's do that subtraction. Add up the digits. 6 plus 5 is 11, plus 5 is 16, plus 3 is 19, plus 8 is 27. So our prediction holds up. So now that we think we have a pattern, we can extend that pattern back to the original problem. So it looks like it's a multiple of 9 times however many 9s and 4s that you have. So that would be, for the original problem, would be 94 times 9. Is 846. So I'm pretty happy with that. I think that pattern's going to hold. I'm sure there's a lot of you out there that are pretty happy with that pattern as well. But I know there must be a few skeptics out there that are not quite convinced by that pattern. I know you're out there saying, well, just because it worked the first 3 times is no guarantee that it's going to work the 94th try. And that's absolutely true. And sometimes if the problem is so hard, we just have to have faith in our pattern. But in this case, I think we can do a little bit more work to convince some of you skeptics out there that we've got the right answer. So how we should go about doing that is related back to the little trick we used back here. So we can apply this same trick, adding 1 to those long string of 9s and then just subtracting 1 from it back with our original problem. So if we do that, we'll have a 1 followed by 94 zeros minus 1 in parentheses times our string of 94 fours. So let's just actually go ahead and do that and see where it takes us. So this is a good example of, as we work through the problem doing the simpler problems, we might come to a few ideas that we didn't have before when we first started the problem. So let's write it out. So we've got 1 followed by 94 zeros minus 1 times 94 fours. So when I multiply that out, I'm going to get, for the first term, using distributive law, I'm going to get 94 fours followed by 94 zeros minus 94 fours. So let's just actually write that out and do the subtraction. So I'll have the 94 fours, 94 zeros, and the 94 fours will line up exactly with my 94 zeros. So I'm going to borrow, and now I've got to borrow from every one of these zeros all the way down the line until I come to my first 4, which becomes a 3, and then I don't borrow anymore. So now we'll do the subtraction. So the first digit is a 6, second is a 5, and then we're going to get 5s actually all the way down that row until we come to our 3, and then the rest will be 4s. So how many do we have? Well, we've got 93 4s, because one of our 4s we had to borrow from to make it a 3. We've got 93 5s, because one of the initial subtraction here was a 6. And when we write that out, we can do 93 times 4 plus 93 times 5 plus 3 plus 6. Well, that's 93 times 4 plus 93 times 5 plus 9. So we'll factor out the 93 times 4 plus 5 plus 9. That's going to give us 93 times 9 plus 9. Factor out the 9. We get 93 plus 1 times 9. Well, that's 94 times 9. Well, what's 94 times 9? Let's go back to our original work. That's exactly what our pattern told us to do. We took 94 times 9, we got 846. So 94 times 9 in this case is going to give us 846. And that confirms our original pattern, that the answer to our original pattern was correct. But doing it this way is actually, there's no approximations here. This is an exact solution to this problem, so we know it's right in this case. And it's very good that it agreed with the original pattern that we found in a much easier way than going through and doing all of this work. So that's just a couple of two different ways to solve this problem. One kind of taking advantage of a pattern to simplify a lot of the work, and the other one is using the nice trick of adding 1 to all your string of 9s to make your multiplication much easier, all to get you back to the same answer of 846. So I hope you enjoyed this one, and I'll see you again next time.